All right, before we go to the lab, we do need to talk about comparable, which is just Java's way of how you compare two things. So what are two things you like to compare?
Sandwiches.
Sandwiches. All right. I'm glad we had this discussion. Yeah, so we'll go in here. We'll go new, Java class, sandwich. Boom. Sure, we'll add that to get. We'll have it implements comparable of a sandwich. And it's going to give me problems because first off, I need to implement the methods of comparable, which is just the compare to function. Now, why am I doing this? If it implements comparable, it's forcing it to implement this function. Comparable is part of the Java util library, and once you've defined something as comparable, you are now allowed to call out Java utilities. For example, sort. Once you have an object that's comparable, you can just call it basically collections.sort, and it'll just sort your list of whatever for you. So a lot of algorithms have been written for you once you implement the comparable interface.
Implements comparable.
Implements comparable and put in the less than greater than the type sandwich. So you're specifically saying it's comparable of a sandwich. So sandwich can be compared to other sandwich or sandwiches. Okay, but before we do that, we need to actually have something of the sandwich. So what do we want in the sandwich? This time let's make it really easy. Just meat. All right. We'll have private int num meat slices. There we go. Public sandwich, which has to be passed number of meat slices, which will just set num meat slices equal to that. That's being passed in. Great. Okay, now the compare to function is going to be a little different because if you're comparing two things, notice it returns an integer. It does not return a Boolean. So it's not telling you, it's telling you more than just true or false. Let's go to the definition of comparable. So we're all on the same page. There it goes. All right, we'll scroll down in the documentation. I thought I saw it. Compare to. So methods that it has returns an integer. Compare to of some object on T, which is sandwich in our case. Compares this object, aka the executing object, with the specified object for order. So it's comparing self to the object that's being passed in. Returns a negative integer, 0, or positive integer as this object is less than, equal to, or greater. So it's going to be negative if self is less than the other one. It's going to be 0 if they're equal to one another, and it's going to be positive if they're greater than one another. Okay? Now, so how are we going to put an order on sandwiches? Obviously, a sandwich with more meat, sorry, all vegetarians, we'll consider is greater than the ones with fewer or less. So how could we code that up real quick in our compare to function?
Number of meat for one is greater than number of meat for another.
All right, so if num slices is greater than s dot num slices, then that means we're greater than the other one, so we'd want to return a positive number, so we could say 1. Else, if num slices is less than s num slices, then we'd want to return negative 1.
Return 0.
Otherwise, we just return 0, so we'll let it exit out. All right, this is definitely one way to do it. Can anyone think of an easier way?
I mean, you could use a switch statement, but that's not quite.
Notice the definition states you're returning negative, 0, or positive. It's not saying it has to be negative 1, 0, or 1. It can be any negative, any positive, and 0. So what you can do to make this a lot easier is just return my number of meat slices minus what's being passed in. Because if they're equal, then it's 0. If I have greater, I have more, that'll be positive. If the other person has more, it'll be negative. I'm leaving both pieces of code up there because they do the same thing. You see what I did there? The top one is probably more intuitive for y'all right now, but the bottom one is the same. So I'm going to leave them both up there. For your lab, you're free to do either. Do whatever is easier for you. I just want to show you why compare to was written the way it was. Okay. So let's go ahead and make another little, did I make it inside of inheritance? No, here we go. New inheritance sandwich list. Let's go ahead and show you the public static void main string args. All right. So if I were to, I don't know, let's make a list of sandwiches. Sandwiches equals new array list. So let me go ahead and include these things. Alt-Enter to import that class. Go over to array list, Alt-Enter, imports that class. Notice when I did that, it added the import up here on top. Is anyone having trouble with doing that for your IntelliJ? I had students have trouble with that last time, but I guess not this time. Being able to automatically import what's needed. No trouble? Great. So we have an array list of sandwiches. Right now, how many sandwiches are in there? This is is everyone still with me? How many sandwiches do we have inside of sandwiches? None. All right. Not tricky. That was just to make sure you weren't all falling asleep, okay? That's all. That's it. So I'm going to go ahead and let's go ahead and add, I don't know, let's add 100 sandwiches. So we'll go, whoops, I is less than 100, sandwiches dot, ooh, look, I can go down and figure out what I want to do. I'll just add one sandwich. We'll do new sandwich being passed math dot random mod. Now let's see. We'll do mod 1,000.
And that means it'll be from 1 to 1,000.
Yep. Cannot be applied to a double. We also want to do math.abs because we want to take the absolute value of that. And then math.abs returns an integer, so a double, so we'll just cast it to an int. All right. Let me say what I just did again. You get a long piece of code like this, it looks complicated. Start at the right, go over until you have your last close. Then you look here and you say, okay, I'm doing math.random, modding it by 1,000. You look up math.random returns a double. So it's going to return a double, hopefully from 0 to 99. I'm going to take the absolute value of that just to make sure that it's positive. You can see right here it's highlighting that open parentheses and that open parentheses, so you know it's being passed at absolute value. Then I'm casting it to an integer, so it goes from a double to an integer, and I'm passing that integer to a sandwich. So what is, semantically, what is this highlighted piece of code doing?
Populating this array list with 100 sandwiches that have a random amount of meat.
You got it. Okay, let's go ahead and go back to sandwich. One thing I don't know if I made too clear, if I for int i's less than, oh wait, we shouldn't use that, we should use the iterator because we've taught about iterators. It equals, let's see, sandwiches dot iterator. And I can do, well, let's go ahead and import that. Notice I have my cursor over it, iterator, Alt-Enter, and it automatically imported it up top. I go while it.hasNext. We'll just do system.out.print. We'll just print .next. And I just realized I didn't do the iterator correctly. We want it to be of a sandwich. So now it.next will return a sandwich. Perfect. And let's go ahead and add a space. Oh no, we'll just print them all out, one line at a time. Boom. If I run this right now, it's going to give me a bunch of memory locations. CSU sandwich at this ID. Well, that's not too useful. We really want to print out the name, or the number of slices. So to do that, we overload the toString. I do believe I've gone over this before, but this is a good review. And the toString function is what's called when they want to convert your object to a string. So by overriding this, we can just do return m number of meat slices, and we'll wrap it around some solid brackets so it'd be easier to see. Okay, and now if I run it, it actually prints it out. Uh-oh, we're all a bunch of zeros. That ain't good. That means something's wrong up here. So there's something wrong with our math value, so let's go ahead and do some quick debugging. Let's see what math.random prints out all the time. Oh, math.random gives us a value from 0 to 1, so my mix-up was not percent, I meant multiplied. Now if I run it, there we go. Wow, 934 meat slices. All right. Did everyone follow what I did there?
So math.random does give you a value between 0 and 1?
0 and 1, yes. Which also means I didn't need the absolute value. So we'll go ahead and remove that real quick. Clean up the code a little, run it again. Shoop. Oh, I didn't like that. Oh, because we wanted to do the math.random first. We want to do the multiplication before it does the coercion. And then there you go. All right, great. So if I keep running this a couple of times, we keep getting a bunch of random numbers that are definitely not sorted. The beauty of this is if we just go collections.sort, passing in our sandwiches, we'll go ahead and Alt-Enter on collections, save that, run it, they're now automatically sorted for us. So we did not have to write a sorting routine. Did y'all do sorting routines? No sorting routines yet? Okay. We didn't have to write a sorting routine, which can be complicated depending on which one you choose.
What if you had what if that was an array of strings?
Strings implement the compare to function based on lexicographical ordering. So it would also sort the strings. But what we did here is we declared our own sandwich class, made it comparable, therefore I could send it to collections.sort. I'm done. I didn't have to write a sorting routine. It's already there for us. Okay. Any questions about comparable? Nothing? All right. What's nice is there's just one sort function, and as long as your object implements comparable, you can use that function. They didn't have to write more than one sort function. They just had to write one. All right. Good, I recorded.